xy plane, the graph of a rational function f has a vertical asymptote at x equals 3, which of the following could be the expression for f of x. Now, if a vertical asymptote lives at x equals 3, that means there must be an x minus 3 living somewhere in the denominator and not an x minus 3 living somewhere in the numerator. Okay, if there was a x minus 3 living in the numerator like this guy, that creates a hole. So I don't want you, no. If I have, let me see, x minus 3, you're x plus 3. Oh, you're the opposite of what I want, so not you. You're x plus 3, you're x minus 12. And if you're like, yeah, but there's two x minus 3s up there, does that count? No, it's got to be in the denominator, silly, like that guy right there. Notice you have an x minus 3 in the denominator, an x plus 3, and who cares about these guys? That's all that really matters. And the reason why you want an x minus 3 in the denominator is if this were to equal 0, you would add 3 to both sides to get x equals 3, which is this guy right there. Now, why would we want the denominator to equal 0? Well, a vertical asymptote exists at a place that makes the function undefined, and it's undefined when the denominator equals 0. So I gave you a little bonus for this problem. But yeah, pretty simple. That's how you do it. Hope this helps.